Welcome class. So in last class we were studying about the frequency of sound, and in today class we will continue from there. So in last class I explained you what is the definition of frequency. Number of oscillation per unit time is known as frequency. So frequency is equal to number of oscillation per unit time is known as frequency. Now, how you can interpret frequency? Let's learn about that. Suppose you are beating a drum. Okay, you are beating a drum. So, how many times you are beating the drum divided by time? How many means number of time you are beating the drum divided by time is called the frequency of your beating the drum. You can interpret or understand frequency from this example. We know that when sound is propagated through a medium, this is one figure of sound propagating as density variation. It means here in the compression region, the number of particles are more than rarefaction region. Then compression region, there is consecutive compression rarefaction region. This diagram shows the density variation in which way sound propagate. This is pressure variation of sound propagation, and this is the graph. In last class, I explained that where crust is formed, the curve of graph is like that, and in the rarefaction region, the curve goes downward. Then compression region, then rarefaction region, and that's how sound wave propagate. And the distance between two consecutive crust or two consecutive trough is called its wavelength. And if this is one frequency, then how many times this diagram followed is called the frequency of the sound wave. The distance between this average pressure and the crust is called amplitude. What it is called? It is called amplitude, and sound wave is propagating in this direction, forward direction. Clear class? Density of the medium oscillate between maximum value and the minimum value. So it is clear that if we plot the distance versus density curve, we got a curve like this. Clear? So this is the maximum value of density, maximum, and this is the minimum value of density. So from this curve, it is clear to us that density of the medium oscillate between a maximum value to a minimum value. Okay, and this change between maximum value to minimum value, this curve, let me show it by different color. This curve, okay, is known as one oscillation. And how many times, number of times this oscillation continue divided by time is known as frequency. This curve is known as one oscillation. When the curve begins from 0, reaches a maximum point, then becomes 0, then reaches a minimum point and again becomes 0. This part of the curve is known as one oscillation, and number of time this oscillation continue divided by time is known as frequency of that sound wave. The number of such oscillation per unit time is the frequency of the sound wave. Is it clear, class? The definition of frequency, the number of oscillations per unit time, is called the frequency. If we count the number of compression or rarefaction that cross us per unit time, we will get the frequency. Okay, if we count this compression and rarefaction, how many times it reaches our ear, then this will known as the frequency of the sound wave. And we know that frequency wavelength is represented by a Greek symbol or a Greek letter called lambda. Similarly, frequency is also represented by a Greek symbol called nu, and this is the symbol, a curved V. Okay, this is nu and this is lambda. In physics, symbols are very important because we cannot write whole spelling of wavelength and frequency continuously in all the question. So we use its symbols. So we have to memorize all the symbols. Okay. So wavelength is represented by lambda and frequency is represented by nu. The SI unit of wavelength was meter because wavelength is a length, a distance between two consecutive crests or two consecutive troughs. Similarly, the SI unit of frequency is hertz, named after the scientist Hertz. Okay, this is the SI unit of frequency. The symbol of wavelength, the SI unit of wavelength is meter and its symbol is M. Similarly, the SI unit of frequency is hertz and its symbol is Hz. Clear, class? Where H is capital and when you will write full name, H will be a small letter. The time taken by two consecutive compression or rarefaction to cross a fixed point is called the time period of wavelength. The time taken by two consecutive compression or rarefaction, time taken by two consecutive. Suppose we have a screen here. From this screen, only two consecutive crust can pass. So first this crust pass and after t seconds, second crust pass from this screen. So two consecutive crust take how much time is called as the time period of the wavelength. For example, this is one door. This person is a crust 1 and this person is crust 2. First, this person passed through this door. We noted at that time and then after few seconds, the second person passed from this door. So that few seconds is called as the time period of the wave, which is the reciprocal of frequency. In other words, we can say that time taken for one complete oscillation or the time taken for one complete oscillation is called the time period of the sound. This is more accurate definition. The time taken for one complete oscillation is called time period. Clear, class? So, till now we have learned the definition of frequency. What is the symbol of frequency, SI unit of frequency, and now we have learned what is the time period of a sound wave. It is the time taken by one oscillation, one complete oscillation. Okay. Let's move forward. The time period of a sound is represented by capital T and there is one relation between frequency and time period, that frequency is reciprocal of time period or time period is reciprocal of frequency. time period is reciprocal of frequency. And this is the formula. Nu equals to 1 by T, where nu is the frequency, T is the time period of that sound wave. Is it clear, class? And the SI unit of time is second and the SI unit of frequency is hertz. Okay, let's move forward. So this is one example that a violin and a flute may both play together at same time in an orchestra, but the sound travel through the same medium, that is air, arrived at same time. Let's imagine that you are sitting in an orchestra and lots of musical instruments are getting played. A violin and a flute may played at the same point and both sound will reaches our ear at the same time. Okay, but the sound we received are different. You can differentiate which one is the sound of a flute and which one is the sound of a violin. How can you do that? So now we are going to learn about a next characteristic of sound, that how you can differentiate between two different sounds. How can we differentiate between two different sound? And one of the characteristic which help us to differentiate between two different sound is called pitch. Now what is pitch? How the brain interpreted the frequency of an emitted sound is called pitch. Okay. If anything has higher frequency, means its wave is like this, then we will call higher frequency means higher pitch. How our brain interpreted the frequency of emitted sound is called pitch, and if anything has high pitch, it means it has high frequency, and if any sound has low frequency, then it has low pitch. Clear, class? So what is the definition of pitch? How the how our brain interprets the frequency of sound is called the pitch. If frequency is high of anything, then we will say it has high pitch, and if frequency is low, then we will call it has low pitch. So high pitch means more number of compression and rarefaction is passing from a fixed point at a given time, and low pitch means that low number of compression and rarefaction is passing from a fixed point. Two objects may start vibrating at same time, like in our case of violin and flute, that both flute player and violin player started at same time, but flute has low pitch whereas the violin has high pitch. So our brain can differentiate between those two sounds. Object of different size and condition vibrate at different frequency to produce different pitch. Object which has different size or different condition of vibration can have different frequency, and if they have different frequency, it means they have different pitch, and if they have different pitch, our brain can differentiate between those two objects. The magnitude of maximum disturbance in the medium on the either side of the mean value is called amplitude of the wave. Okay, we have completed the pitch part. Now we are learning about another thing which is called amplitude. So this is distance versus density curve, and the curve look like that. So the magnitude of this maximum distance means the distance from this zero level to this maximum or crest is known as amplitude. What it is called? It is called amplitude of the wave. Maximum disturbance is in the medium from the mean position. This is the mean position. So the maximum disturbance from mean position, or the distance between crest or mean position, is called the amplitude of the sound wave, and the amplitude is represented by capital A. This is a wave, okay, and we can clearly see from the picture that it has low pitch because its frequency is very low. And if we see this one diagram, then this has more frequency. This wave is, this is one oscillation, and it has lot of number of oscillations. So this wave has high pitch. So these two diagrams show the difference between low pitch and high pitch. Okay, so we have showed you the diagram of low frequency and high frequency. Low frequency will have low pitch and high frequency has high pitch, and I have talked about what is the amplitude of the sound. Now let's understand from which characteristic amplitude is associated. So the loudness of the voice of the sound. How loud is the sound is associated by the amplitude. This is one sound wave, and this is the amplitude A. Maximum disturbance from the mean position is called as amplitude, and if the amplitude is high, then the sound is loud. If the amplitude is low, it means the sound is low or soft. So loudness and softness of sound determined by the amplitude. High pitch and low pitch is determined by frequency. Loudness is determined by amplitude. What frequency determine? Frequency determine pitch. And what does amplitude determine? Amplitude determine loudness. Okay, so how higher will be the amplitude will be associated with how much energy we are utilizing in producing that sound, because sound is also a form of energy. How much energy the sound will have, greater will be the amplitude, and if the amplitude will be greater, louder will be the sound. So the amplitude of sound wave depend upon the force or energy with which the object is made to vibrate. If we strike a table loudly, so we are giving the low energy to the table particles, so they will vibrate slowly, and if they will vibrate slowly, the amplitude will be low and the sound will be soft. If I strike my hand on the table very hardly, okay, so I am giving more energy to the particle of table, so the particle will vibrate more fastly or more rapidly, and it will produce a high amplitude, and if amplitude is high, the louder will be the sound. Is it clear, class? So amplitude is anyhow directly proportional to energy. How much energy you will provide will give more amplitude, and higher the amplitude, higher will be the loudness. This is the diagram. If we provide small energy to the particle, these particle will vibrate slowly, and if these particle will vibrate slowly, the curve will come like this. It has low amplitude, so the sound is a soft sound. And if I provide more energy, then amplitude will be higher and sound will be louder. Clear? So amplitude is associated with energy, and amplitude determines how loud the sound is. Can you tell why a sound wave spread out from its source? Can you explain why a sound wave spread out of its source, away from its source? It spreads. Why? The answer is we can determine by listening. We know that near any sound source, near your television, the loudness is high, and as you go further away in your home, the loudness decreases. At one point, it becomes 0. Why this happened? From distance, loudness decrease because energy decrease or the amplitude decreases. Whenever you go away from a sound source, you hear less voice. Why? Let's assume you are standing close to your television. You will hear a louder sound when you start moving backwards or away from your television. The sound will be low, and at one point it will become 0. So why it is happening? It is happening because closer to television, the amplitude of the sound wave is high, so their sound is loud, and as you go away, the amplitude decreases, and as amplitude decreases, sound becomes soft, and at one point it becomes 0. Loud, soft, 0. Clear, class? Louder sound can travel larger distance. Whenever you shout, your voice is heard by a long distance, because louder sound can travel large distance, because louder sound has high energy. Louder sound can travel a large distance as it is associated with higher energy. We have already shown you the shape of loud and soft sound of same frequency. Now we are going to learn about a new term called quality or timbre of sound. Quality of sound is the characteristic which enable us to distinguish between two different objects. In whole class, you can easily distinguish the sound of your friend. How can you do that? It is because you are using the characteristic of sound which called as quality of sound. It helps us to distinguish from one sound to another if both the sound have same pitch or and loudness. So quality of sound help us to distinguish between two different sound if both the sound has same pitch and same loudness. A third factor come in play, which is quality of sound. Quality of sound. The sound which is more pleasant is said to be rich quality. A sound of single frequency is called tone. Any sound which has single frequency is called tone. This is the definition of tone. Have you ever played any musical instrument? Whenever you press one note in a piano, it is one tone because it generates only one frequency. Okay? Sa, re, ga, ma. These are one tone. The sound which is produced due to mixture of several frequency is called a note. The sound which is produced by mixture of several frequency is called note, and sound of only one frequency is called tone. If we hit the table hard, we hear a louder sound. Whenever we hit a table hardly, we hear a louder sound, and that louder sound is not pleasant to us. Similarly, definition of noise is an unwanted or unpleasant sound to our ear. Music is pleasant because it has rich quality, but noise is unpleasant. So it has bad quality. So let's start with, in next class we will begin by solving questions of those topic which we have learned in today's class. It means what is wavelength, what is frequency, what is loudness, what is pitch, tone and note, and also quality of sound. So we will start these questions in next class. I hope today's class is clear to you. Thank you so much.